25 we have the equation y equals secant x, y equals radical 2, and we're going from negative pi over 4 to pi over 4, and we want to find the volume that's generated by revolving the region around the x-axis. So ultimately, in picture-wise here, we know, like we said yesterday, we had secant here. If we just do negative pi over 4 to pi over 4, we know that in general it goes down to 1, goes up as such here for the secant function. So again, goes down to 1. And if we draw the line y equals radical 2, we know that radical 2 is going to be 1.4 and some change, so somewhere in this neighborhood. Okay. All right. So ultimately, the region that we're interested in is this. Okay. And conveniently for us, if we go from negative pi over 4 to pi over 4, which is what they told us in terms of the domain of this, those are the actual intersection points there. Pi over 4, negative pi over 4 makes secant equal to radical 2. So those are the points, negative pi over 4, radical 2, and pi over 4, radical 2. And so if we're going to take this and we're going to revolve it around the x-axis here, and we want to use a vertical slice, then what kind of shape is that going to make? It's going to be a washer. It's going to be a hole, because it's going to go here, and then it'll pick back up over here. So if it's a washer, we know that our general formula then is going to be, in the x direction, negative pi over 4 to pi over 4. And then we need ultimately pi, and then outside radius squared minus inside radius squared dx. So bottom line is then, what is the outside radius here? Well, the outside radius here, what's the distance from here to here? Remember, all we want is the distance from here to here. So isn't it just radical 2? Remember, throughout the region, wherever we drew that slice, is it ever any different than radical 2 from that line to the x-axis? Okay. And then from here to here, that distance is the secant x. That distance depends on where we're at on in the x-plane. So if we're over here, the secant over here, secant wherever it's at is going to be defined by the secant function. So once we do that, then it becomes what? Once we set that up, we can just do calculator. Okay. Yeah.
So wouldn't the square root of 2, would that be the radius from the line to the x-axis? That's what we're
It's
talking
from that. Remember, this is the washer that we have here. This is the washer in 2 dimensions, right? So the outside radius is from the outside of the washer to the revolving line. That's your outside radius.
Okay.
And no matter where we are in the region, it's going to be radical 2. Okay. If we're on the inside of the washer to the revolving line, that's going to be the function, in this case, secant x.